Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to show you in this program is we're going to make a function to print out our employee struct, because we've seen previously that there's quite a bit of work in having to retype all of the information each time. So the first thing that I'm going to do in order to make this work is I'm going to take my structure that I've declared there and I'm going to move it outside of main, and the reason for that is we want that information to be available both inside main and also to functions, so that both of them recognize what it's going to look like. And indeed, a struct like that is something that you could put inside a header file if you wanted to make your own header files. We might have a look at that at some later date, but you could put it inside a header file so that you didn't have to be rewriting all of this sort of thing at the top of a program. Now the next thing I'm going to do is I'm going to make a function, and because I'm writing it above main, it means that if I call it inside main, I won't have to declare it again. But I could, if I was going to write the full definition below main, I would have to at least write a function prototype or a function declaration up at the top. So what I'm going to do is I'm going to make a function. I'm going to return nothing from it, and the reason for that is that it's just going to print out information. We don't need any information back from it. So I'm going to call it employee print. And what I'm going to pass to that is a pointer to an employee. And not going to give it a very descriptive name. I'm just going to call it E, because it's not a specific employee or otherwise, and that's why I'm just going to call it E in this case. Now when we get that, we're going to do some of the things that we have down below here, which are these things here. Except instead of Fergal, we're just going to have the generic name E. So I'm just going to call that E. I'm going to use my pointer syntax, as I said. That's the way we prefer to do it. Okay, and obviously so that we don't get that mixed up with our previous prints, I'm going to remove these printfs. So Fergal is no longer going to be printed in that way. What I'm going to do is I'm going to say Fergal, or sorry, I'm going to call the function employee employee print, and I'm going to pass to it Fergal PTR. Now what I could also do is I could also pass it the address of Sean, and we might try that in a moment. So we'll just try that one first. Okay, and we can see that that's come out correct. It hasn't printed the hourly salary for some reason. I don't know, have I just left it out up above? I seem to have done that. I have the gender, but I don't have the other one. So now remember, I can't put in a euro sign or anything like that. I could put in maybe a pound sign or something, but we'll just say that many, and I can write euros after per hour. We can't obviously use the euro sign because it's written in ASCII code, which is American Standard Code for Information Interchange, and the euro isn't American. But aside from that, it was designed back in the 70s, long before the euro symbol was ever thought of, so that can't be included in it. Oh, sorry, printf. Just make sure that that's all coming up there, and it is indeed. It's not earns, because I've forgotten to actually put in the detail at the end here. So comma, So hopefully you were screaming at the screen there that you spotted that I had left that out, and you thought I was going to manage to do something magic. Okay, so hourly salary we've put in there now. Okay, and it's coming up with the correct number. Now, that was obviously with the pointer to Fergal, and obviously this was expecting a pointer, so that was fine. But what would we do if we wanted the Sean one to come out? So let's try this first of all. Get rid of all the Sean material here. And what we're going to do is we're going to call, and we can do this fairly early on here. I mean, I can do it here. Address of Sean, and let's see how that goes. Okay. Oh, you have written it the wrong way around. I've said print employee and it's employee print. Okay, and as you can see there, all the information is coming up correctly. Okay, now one of the things that I want to mention here at this point is, and it's not vitally important for what we're doing here, but one of the issues is that the employee print function is just meant to take the details of the employee and print it out. It's certainly not meant to make any modifications to the employee structure. And so the person who calls that function employee print, they expect that the thing is going to get printed out, but it's certainly not going to get modified. But there's nothing to stop whoever owns or runs this function here, who's written this, and remember this could be in a very large piece of code where one programmer is writing this part and they never see the programmer, or they never see the program that writes this part. So we could have an issue there whereby the person writing the employee print function might decide to modify it and may decide to modify the structure. And the person down here might not want that to occur. So they may not trust the function unless they're told explicitly that nothing will be modified. And rather than write that in terms of a comment or something that's written on the function, what you can actually do is the following. You can use the keyword const, and what that says is that I'm not going to modify any of the details here. Okay. Okay, and as you can see, it's made absolutely no difference other than we're not going to change it to something else. Now, just to prove that that's the case, what I'm going to do is I'm going to pretend I'm the person with the employee print function, and I'm going to make a modification to it. So I'm going to say age is assigned 23. Okay, which is different from original one, and we'll try and just do something there, and you can see assignment of member age is read only object. In other words, it's not happy with me doing that because it's saying no, you've said you wouldn't modify this, so it throws a compiler. So you can see how the that would be an issue, because if we pass in the pointer to Sean previously and they go and modify it, it modifies it back where the original one is, and we don't want that. Okay, so if we put in that const, it just makes it a little bit safer. And these are little things that you can do in order to make sure that you don't make a mistake yourself in your program later on by making a modification to a function that really shouldn't be doing it. And it's just a little bit more exact about how you go about things. Okay. We'll do a little bit more on those consts and so on at a later date. And what part of the thing is discussing exactly what is constant and what is not. And const is a difficult one because unlike many of the things that came from that, where C++, the language C++, took things from C, const is something that was introduced a little bit later. It was introduced in C++ and then brought back into C, but they work a little bit differently. So it's one to just be wary of from that point of view, particularly if you ever program in C++ as well. Okay, but for the moment, I just wanted you to see that we can actually make some of these things constant in order to make sure that they're not modified.